Hi everyone, welcome back to MAC1105. In this video, I'm going to show you how to solve radical equation. Solving radical equation is not really that hard, but you have to, it requires some trick and you have to follow the formula. In the previous section, we already learned what radical function is, and we know that when we talk about radical, we have the n is even or odd, right? We have even radical, we have odd radical. So in this video, again, we're gonna learn how to solve even radical equation and odd radical equation. Okay, so let's get started. Section 5.5. Excuse me. Radical equation. Okay. In the textbook, they also mention radical inequality, but in this course, we just focus on radical equation. Radical inequality is harder, but if we have time, we're gonna go through that. But if we don't have time, I think I'm gonna focus on radical equation only. Okay, so again, I'm gonna divide into two parts. It's even radical equation, and we're gonna focus on the equation that contain one radical only. Okay, all right. Hold on, just okay. So we start with our first example here. In this example, we have only one radical. Okay, so example is something like this. We have square root, because this is even radical. So square root is the typical example of even radical. 11 minus x. 11 minus x equal 1. Oh, I forgot to give you the formula. I'm sorry. So let me put this in. Let me put this later. Let me give you the formula first, because as I said at the beginning, when you solve radical equation, you have to follow the formula. Like it's kind of the same thing as you solve an absolute equation. Okay, so the formula is if you have absolute of a. No, not absolute. Sorry. If we have radical of a equal b. Okay, then this equivalent to square root of a square equal b square. So what does it mean by this formula? It means that if you have radical something equal to something, then when you square both sides, okay, this could be when you square both sides, it's gonna the statement the equation you obtain after you square is equivalent to the original equation. That's what I mean. Okay, so for all radical equation, every time you solve radical equation, doesn't matter, even the odd radical equation, you try to bring it back to this form. You always try to. Okay, even though that the question gives you the equation that contains two radical, you must be able to bring it to one radical. If you have two radical, you cannot solve, so you must convert it to one radical. Okay, example. Now we're gonna do example. We have square root 11 minus x minus x equal 1. So the good thing is in this example is that we have only one radical. Okay, but the thing is that we have to check if it is in the form yet. Look at the form. You see that in front of the radical we don't have anything. Actually, it is an invisible number 1 here. After the radical we don't have anything. Then it equal to b. However, if we look at our example here, after the radical, right, to the radical, we get stuck with the negative x. So we have to get rid of negative x. So in order to get rid of negative x, you're gonna add both sides by x, right? Okay. When you add both sides by x, my equation becomes 11 minus x equal to x plus 1. Okay. So now, after I eradicate the negative x, so you see that the equation I have over here is in the form already. So basically, right over here is a. Right over here is a. Okay. Okay. Oh, and over here is b. Okay. So it's in the form already, and as long as it's in the form, we can square both sides. So I'll go ahead and square both sides. We square both sides like this, and x plus 1 square like this. When you have a square root of something square, you can go ahead and throw away the radical. It means over here you have 11 minus x. But over here, x plus 1 square, if we do on the side, x plus 1 square is actually x plus 1 times x plus 1, right? Okay. And then you're going to go ahead and void them, distribute them. After you distribute and you combine like term, you will have x squared equal to 2x plus 1. Okay? Alright. Alright, so right now, what equation is? This is quadratic equation, right? Now, we're going to bring everything to one side. Okay, so I'm going to go ahead and add both sides by x. So you have x squared plus, add x over here, add x over here plus 3x. Then I'm going to subtract both sides by 11, so you have negative 10 equals 0. And we have quadratic equation, and everybody knows how to solve quadratic equation. You can just go ahead and factor them. So you have x here, x over here, and then plus 5 here, and minus 2 here, right? And we can go ahead and split them out. Or x minus 2 equals 0. So you have two values, x equal to negative 5 and x equal to 2. So we have to go back and check which one is the solution. Okay, let's plug it over here. So we're gonna look like that. This one is solution, and this the negative 5 over here, negative is 11 over 16, right? 16 square root of 16 is 4. 4 minus 4 plus 6 is 4 plus 5. So this one is not. It's not equal to 1, right? So this is not the solution. Then my final solution will be this only. Right? Because x equal to 11 minus 2, 9, square root of 9 is 3, 3 minus 2 equal 1. So there we have only one solution. Okay. Alright, let me give you another one. Okay. In this one, I'll kind of play with you a little bit. I'm kind of disorder everything. How about something like that? Equal x plus 3, for example. Okay, so again, our approach is to bring it to this form. Over here we have the radical already, so we're getting stuck with number 2 here. So I'm going to go ahead and subtract both sides by 2. So you have x 3 minus 2 equal 1. So you see that in front of the radical, we're still getting stuck with 1 over 2. So I'm going to go ahead and multiply both sides by 2. Alright, so let me use the different color over here, so that you know that I multiply both sides by 2. Remember, when you multiply both sides, and this side over here is the sum, so you gotta put parentheses, right? Then when you multiply, after you multiply both sides, you can go ahead and cancel out. Then my equation becomes square root of x minus 1 equal to 2x plus 1, right? And now what we have? We have what? We have over here, we have 2 multiplied by the parentheses here, so it means we can go ahead and distribute them. So 2x plus 2. And now, what we have here? We can recognize this is A, and this is B, right? And now we can apply the formula, which is we're gonna go ahead and square both sides, right? So you have x minus 1 square equal 2x plus 2 square. Okay, so x minus 1 square is just x minus 1. 2x plus 2 will be 2x plus 2 times 2x plus 2. We're going to go ahead and void them and combine line term. So you have 4x squared plus 8x plus 1. Okay, this is quadratic again. So we go ahead and move everything to the one side. Minus both sides by x, so you have 7x. Add both sides by 1, so plus 5 equals 0. And we have the quadratic here. Okay, and let's see that this quadratic over here has solution or not. Now we don't have to put into the quadratic formula. We just need to check the discriminant. What is discriminant? Discriminant is b squared minus 4ac, right? Okay, so let's check it. B squared is 49 minus 4, a is 4, c is 5, right? So equal to 49 minus 80. Alright, so this is a negative value, negative 31, right? Yeah, so this is negative value. So the discriminant is negative. It means that this quadratic equation here doesn't have solution. Okay, so this one doesn't have solution. It means the whole. Okay, it means everything, the whole radical equation here, it doesn't have any solution. So I'm gonna go ahead, jump into final conclusion. No solution. Okay, no solution. Okay. So you see that even though that I disorder the equation a little bit, but I mean you can still apply the formula after you reorder in the form square root of a equal b. Okay. So on the third example, I'm going to give you even root equation. Again, it's still even root equation, but instead of containing one radical, we have two even root, two even radical. So I have something like this: square root of 2x plus 3 minus x plus 1 equal 1. Okay, equal 1. So in order to deal with this one, okay, there's at least two different approaches, but I think that you should stick to this approach. If you have two radicals on one side, it is best that you always want to put one of them to the other side. So you're gonna have two radical. So you're gonna have one radical on each side. So I'm gonna add in both sides by square root of x plus 1. Okay. Afterward, you're gonna go ahead square both sides. So go ahead square. So go ahead square. Okay. So when you square root of 2x plus 3 squared, it gives you 2x plus 3, right? But this one, you have to write it as 1 plus x square root of x plus 1 times 1 plus square root of x plus 1, right? Okay. Then you have to void them. Then you have to void them. So let's void them. So let's go ahead and void them. So let me put the arrow here. So this one go over here. This one go over here. This one go over here, and this one go over here. So let's see what you get after you void. So 1 times 1 is 1. 1 times this is radical x plus 1. Radical x plus 1 times 1 is just radical x plus 1. Radical x plus 1 times radical x plus 1 will be radical x plus 1 square. After you void it, you're going to combine like terms. So you have 1 radical x plus 1 plus radical x plus 1 will give you 2 radical x plus 1. And radical square root of x plus 1 square give you x plus 1. Right? Something square root of something square give you itself. So you're going to combine line term here. So 1 plus 1 is 2 plus x plus 2 radical x plus 1. And now we're going to go ahead and try to bring it to the form. So originally you see that we have 2 square root. Now we have only 1 square root. You see that? When you have 1 square root, you have to bring it to this form. You always want to bring it to this form. Okay, so I'm going to go ahead and subtract both sides by 2. So I will have 2x subtract, so we have 1 equal x plus 2 x plus 1. Then you're going to subtract both sides by x. So 2x minus x will be x plus 1 equal to x plus 1. Okay, so right over here, it looks like that we can reorder them so that it's going to have something like this. It's going to be something like this, right? So according to in order to apply the formula, you see that in front of the radical we don't have anything, but over here we have something. So some of you go ahead and divide both sides by 2. That is okay. But when you do so, you see that on this side you can have x over 2 and 1 over 2 when you divide both sides by 2. Right? You don't want to deal with fractions. So this is what I recommend you to do. So I'm going to go ahead put everything inside the radical. So go ahead put it back in. So basically you go ahead and distribute them back in. So you have 2x2 times 1 is 2. 2 times x is x. So go ahead, basically it's distribution, but it's not distribution because we don't have distribution property for radical. But you can go ahead and put them back in. Oh, let me see. You have to be careful because when you put them back in, okay, when you put them back in, I'm sorry, I forgot to mention this. When you put them back in, remember the number when you take square root, it give you 2, will be number 4. Okay, will be number 4. So let me erase this. Will be number 4, right? So when you put into the radical, it's not just like distribution, because I say that we never have the distribution property. But when you put it back in, basically you square it. Okay? You put it back into the radical, basically you square it because when you take square root of 4, give you 2 outside. You see that? Okay, so after you put everything into the radical, and now you can recognize that. You can recognize this is basically is a right here. And this is your b right here. Now we can go ahead and square both sides. So go ahead and square both sides. So you're going to have 4x plus 1 square both sides equal to x plus 1 square. Okay. And when you take square root of something square, so that it will give you itself, and this one is give you x plus 1. X plus 1 square is x plus 1 times x plus 1, right? And you go ahead distribute it. So it will be x squared plus 2x plus 1. And this is implies equivalent to 4x plus 4. Go ahead distribute them in. Okay. Equal to x squared plus 2x plus 1. And now we have the quadratic, right? So I'm going to go ahead and subtract both sides by 4x. So give you negative 2x. And I'm going to go ahead and subtract both sides by 4, give you negative 3, right? Okay, equals 0. And now we can go ahead and factor this. So we have negative x minus 3, x plus 1 equals 0. And from here, I'm sorry, I'm going to have to write up here because we don't have enough space. I can go ahead and split up 0 product property. So x equals 3 and x equals negative 1. Okay, again we have to check. Okay, we have to check. Let's see which one is the correct answer. And look like both of them is the correct answer. So if both of them is the correct answer, then just go ahead and box them. So this is your answer. And this is your answer. Make sure that you always have to go back and check. Okay. Good. Okay. Now, what if I have two radical? Example 4. Okay. What if I have two radical also, and it's not something like this. Okay. What I mean over here is that there's another formula, not this one. Okay. And this formula is also very helpful to help you solve radical equation. The formula is as follows: if you have square root of a equals square root of a, then you can go ahead and square both sides. Okay, and if you go ahead and square both sides, okay, you go ahead and square both sides. If you go ahead and square both sides, right, then basically square root of a squared is just a equal b, right? So you can apply this formula, okay, in some cases. I'm going to give you an example right now. So on the next example, I'm going to have something like this. So it's 3 examples. Example number 4. Okay. What if I have something like that? I have a square root of x plus 1 equal to square root of 4x plus 1, 4x minus 3. So I have something like this, and this is already in the form, right? Square root of a and square root of b, and then, so we know that this is a, and we know this is b. Then we just go ahead and square both sides. So basically, we just go ahead and put everything square like this, and everything square like this, right? And we just, if we go ahead and put everything square like this, we basically go ahead and throw away. We can go ahead and throw away the radical, right? And when we throw away the radicals, basically we have the linear equation, and we can solve for this. We subtract both sides by x, right? Then we add both sides by 3, so we do 4 equals to 3x. Okay. Then you divide both sides by 3, so you have x equals 4 over 3. Equal 4 over 3. And if you go ahead and plug them in, so let's say it works out. So 4 over 3 plus 1 is 7 over 3. And over here 16 over 3. 16, you find LCD. 16 over 3 minus 3 could be, LCD could be 3. So 16 minus 9 could also 7 over 3. So both of them the same. You see that? So this is the final answer. See, I always check. I always check. Now, what if I have something like that? I have 2 square root of x minus 1 equal to 3 square root of x plus 2. What if I have something like this? So there's a couple different approach. The best approach that we can go ahead and put everything inside the radical. So if you put everything inside, you get a square root, so give you 4x minus 1. So you square this, give you 9x plus 2. Then you're gonna go ahead and square both sides. Okay, so go ahead and square both sides. Okay, go ahead and square both sides. And when you square both sides, you can go ahead and throw away the radical, right? So you're going to have something like this. And this is basically this. So you're going to have 4x minus 4 equal 9x plus 18. Subtract both sides by 4x, so we have 5x. And subtract both sides by 18 equal to negative 22. So your answer will be x equal to negative 22 over 5. And we're gonna see that it's gonna, if it work or not, and look like it's not working already, right? Because over here negative 22 over 5 minus 1 gives you negative number, and you cannot take square root of negative number. So this one is not working. Okay, so we can get the conclusion is no solution for sub-equation. Okay. There's another approach. You can go ahead and set up proportion here, but I recommend you not to use it because some of you are not familiar to proportion, so you shouldn't do that. Okay. All right. Okay. So far we've been dealing with all even root. Well, for the 4th through 6th root, you do the same thing. Okay. Now let's deal with odd root. So in the first part we have even radical equation. The second part we have odd radical equation. Okay, I'm going to put odd radical equation. Okay, odd radical. And a typical example of odd radical equation is we're gonna go ahead and raise the general approach. Okay, and general approach, strategy is to raise both sides by that odd root, by the odd root, by the odd, raise both sides by that odd root. So what I mean over here is this: if you have cube root, you're gonna raise both sides by the 3rd degree. If you have, so I'm gonna put here, I'm gonna raise both sides by the odd degree, by the odd root degree. Just go ahead and really specify like that. So if you have 5th root, you're going to raise both sides by the 5th degree, something like that. Okay. Alright, so let's jump to our example. I'm going to have something like this. Let's see. What if I have cube root of 3x squared plus 7 equal to cube root of 7 minus 4. So I'm going to go ahead, you see that this look like it's in the form something like this, but instead of the 2nd root, right, we'll have odd root, right? So I'm going to go ahead and raise both sides by 3rd degree. So go ahead and raise both sides by 3rd degree. And when you raise both sides by the 3rd degree, you just go ahead and throw away the radical. And now we have the quadratic equation. So go ahead and subtract both sides, add both sides by 4x, and you cancel this, equals 0. Now we can factor this, 3x plus 4 equals 0. Then we can split up x equals 0, or 3x plus 4 equals 0. And x equals negative 4 over 3. Okay. And we gotta go check again. Negative 4 over 3 will be 16 over 9, so it's gonna be 16 over 3 plus 7, right? And over here will be 16 over 3 plus 7. Yes, so this is This is the correct answer, and also 0 is correct answer. So both of them is correct answer. Both of them is the answer. Okay. Well, if you have only one third root, then everything will be easy, right? You just go ahead and raise everything to the third degree. But what if you have a fifth root equal 1? Well, you're gonna do the same thing. You just go ahead and raise both sides by the fifth degree. Okay. So you have 2x plus 3. You're gonna raise both sides by the fifth degree, so 1 to the fifth degree, right? Alright. Then if you raise both sides to the fifth degree, you can go ahead and throw away the radical. Okay, 1 to the fifth, the power is 1. So you go ahead and subtract by 3, so give you -2, and x equal -1. And again, we gotta go back and check. -1 times 2 is -2, 3 minus 2. So yes, so this is the final answer. Okay. If you know how to do the even radical equation, I mean for odd radical equation, everything will be very easy, super easy. Okay. But if you have over here, what if you have a third root over here and you have fifth root on the other side? What if you have something like this? What I have over here, keep of x plus 2, right? And over here we'll have fifth root of 2x minus 1, right? Then you gotta be careful. This one could be very hard. No, it's kind of very. It's not gonna say. I'm not gonna say that it's super hard, but there's some trick to solve for this. Okay, I'm gonna put it over here for you as the challenging question. Go ahead and try to figure it out. Let's see if you can do this one or not. Okay, all right. So I'm gonna stop my lecture over here. Please let me know if you have any question. Go through all the example, and if you have any concern, just send me a message through Canvas. I'm gonna see you next time. Bye bye.